Hello, guys. My name is Desmond, well known as Dish, and I welcome you to my YouTube channel. So, guys, I'll always mention that if you're watching this lesson from one of my platforms, it could be Facebook, Instagram, or Twitter. And again, you might be watching this from TikTok. Guys, just be aware that I've posted a full lesson on this question on my YouTube channel. So currently we are live, but then as soon as we are done with this live lesson, I'll make this lesson available on my YouTube channel. And again, as you can see, today we'll be dealing with electric circuits. So if you wish to access this question paper, just visit my Telegram channel. If you've got a Telegram account, you can just search for solving exam papers. That's where you'll be able to access this question paper. So I post all the question papers for high school, not necessarily for the subjects that I treat, but for almost all the subjects that you can think of we should do in high school. So guys, please do make sure to subscribe and hit that bell notification so that you're notified of our future uploads. So I won't waste any much time. So for now, we'll just start with the business of the day. So this question, it's question 9 of exam paper of November 2015. So this lesson is suitable for grade 10s, grade 11, and grade 12s. And again, if you're upgrading your physical sciences, this lesson is also suitable for you. So, ladies and gentlemen, we are given a question. As you can see, question 9, you're advised to start this question on a new page. Okay, so I'm just quickly going to read through that statement. And again, as usual, we're just going to go through that given a diagram and of course analyze it a bit before we start with the questions. So guys, the statement reads as follows: a battery with an internal resistance of 1 ohms and an unknown EMF is connected in a circuit as shown below. A high resistance voltmeter V is connected across the battery. A1 and A2 represent ammeters of negligible resistance. Okay, so that is the statement that we're given, and we're also given a circuit below. As you can see, I've tried to draw that circuit there. So guys, remember at all times what I draw by hand doesn't necessarily mean that it's drawn to scale, and again, it shouldn't in any way be compared to the circuit given or the diagram given on the question paper. I was just trying to draw it such that it looks almost the same. But regardless of that, a hand-drawn diagram not being to scale, it doesn't necessarily mean that it's not accurate or it won't serve the purpose that it should serve, which is just for ease of reference. Remember, from time to time, you might find that the information that we get as we calculate, I might just write it there instead of having to write it on my screen because I'll be scrolling up and down. So, guys, again, we've got a mini statement there which says, with switch S closed, the current passing through the 8 ohms resistor is 0.5 amperes. Okay, so guys, as I've indicated, let's just quickly try to analyze that circuit. Okay, so let me talk about the battery. Okay, so we've got 2 cells as you can see there. Okay, so ladies and gentlemen, a battery is the combination of 2 or more cells. Okay, so when you've got this long line and a smaller line, just know this is 1 cell. Okay, and combined with a long line and a smaller line, then you know you've got 2 cells. Okay, So the combination of two cells or more, it's what we call a battery. Okay, I hope you understand that part, right? So now, ladies and gentlemen, within a battery, okay, within a battery, you might have an internal resistance. So that means, let's say for instance, the power of each cell was 1.5 volts. 1.5 volts. Now, because we talk of a battery, which is the combination of those two cells, that means we've got 1 plus 1 plus half and a half, which is equals to 3 volts. Okay, so that means the combination of those two cells, which forms a battery, has a 3 volts. Okay, so what it means by internal resistance, which is represented by a small r, in that case, it's 1 ohms. Okay, it could be 0.5, it could be 0.8, whatever number it is. It means the voltage which is going to supply anything connected to that circuit will be less than 3 volts. Why? Because part of that 3 volts will be resisted by that 1 ohms resistor. So the 1 ohm resistor will resist some of the voltage. It will retain some of the voltage within that battery. Okay, so the other thing that I want to talk about is that this 3 volts, it is referred to as the EMF. So the EMF is the total voltage of those two cells. Okay, that is the EMF. So the moment we've got an EMF and again we've got an internal resistance, then we know not all 3 volts will be used by whatever that is connected to that circle. So you might find that maybe only 2.7 volts it will be shared amongst those connections. Okay, so that means what is it, 0.3 volts will be lost as a result of that internal resistance. So that internal resistance, it resists some of the voltage from being used. So only 2.7 will be used. Okay, so guys, I'm just trying to make it as simple as possible just for you to be able to understand. Okay, you don't need to stress that much. This information that I'm providing is just for you to be able to easily understand the circuits. Then at a later stage, when you're fully confident with the circuits, that's when you can be able to try and make sense out of the voltage, current, resistance, and everything. Okay, so now the other thing that I want to talk about, which is not that much important, just know that this long line, it represents the positive side of the battery, the shorter one negative side of the battery, long one positive, shorter one negative. So current flows from positive all the way up to the negative side. Okay, so that means this is the direction of the current. So that means the current will flow from the battery from the positive side all the way up to the negative side. Okay, so guys, the other thing that I want to talk about, it's the voltmeter and the ammeter. So those are the devices. A voltmeter is used to measure the voltage. So in this case, they've connected a voltmeter across the battery. Okay, so we've got voltage, we've got voltmeter. Okay, so you know the word meter, a water meter reading. Okay, you might have heard of a water meter which reads the volume of water passing through a point. Okay, so now in the circuits we've got what we call a voltmeter and ammeter. Okay, So the ammeter reads the current and the voltmeter reads the voltage. Okay, so don't be confused, guys. When you see a circle with a V, just know that this thing is a meter, okay, which reads voltage. When you see a circle with A, this is an ammeter which reads the current. Okay, so that means on this circuit we've got 3 meters. We've got the voltmeter, we've got the ammeter and the ammeter. So now because we've got 2 ammeters, they are now referred to as A1 and A2. So that means A1, which is ammeter 1, it reads the current passing there, okay, and A2, it reads the current passing there, okay. So guys, the other thing that I want you to notice, I'm not sure if you already noticed what I want to talk about, but if you can have a look at this circuit, you will realize that we've got 2 types of connections. Obviously, you know the 2 types of connections. We've got a series connection and a parallel connection, okay. And again, within a parallel connection, we still have another parallel connection. So I just want you to pay attention to this and you'll realize what I mean when I say I've got 2 types of connections, because it might look as if we've got just one type of connection, which is parallel. So I've tried to make to draw that diagram in different colors. So we've got this part which is drawn in black, which represents the external part of the circuit, and from that point and that point there, this is where you've got a parallel connection, okay. So within this parallel connection, you still have a branch there, which is a parallel connection, okay. So that parallel connection is connected in series with that 20 ohms, okay. So remember, guys, at all times when you've got a parallel connection, you can combine it or convert it from parallel to series. You already know the formula to convert a parallel connection and convert it into a series connection. So guys, let me just draw this part. Let me just draw this part and do this and do that. I just want to show you how it looks like when it's being converted. What else have we got? Okay, something there. We've got R, and then we've got A2 there, and it goes like that. Okay, I just want us to concentrate on that portion there. So we've got A1 there. Okay, so now guys, let's just say this is R1, this is R2, this is R3, and this is R4. Okay, so what I'm trying to say is we can convert a R1 and R2 into a series connection, because this is a parallel connection. So that means we're going to then have I'll just draw that portion there. So it's going to be this ammeter there and R4 there. So this is R4, then this is R1 plus R2, okay. Then we have R3 there, we've got ammeter 2 there, okay. So this is R3. So guys, I'm just showing you how to convert this branch into a series connection. So this is how it looks. We can now combine these two, because that's what I meant when I said we've got 2 types of connection. So this connection on its own, it's a parallel connection, okay. It's a parallel connection, and within this parallel connection you have a series connection. So that means you can have I'm not sure if that space will be enough. Let me just do it this way. You've got that ammeter 1, and then you've got, this is that R3, this is ammeter 2, and then you've got that. I hope you're able to see, guys. So that means we've got R1 plus R2 plus R, that is R4. Okay, so guys, in this way, it's more like now we've converted not necessarily converted, but we've combined this connection which is in series into one resistance. Okay, so again, if we want to now combine these two, we can just do the same, and it will look something like that, where you've got, let's say, just one series connection. Obviously you will have an ammeter there, then that means it will be R1 plus R2 plus R4 plus R3. So that is combining this parallel connection. So guys, this is not part of answering any question. I'm just trying to indicate to you that when it comes to the circuits, you've got two types of connections, which is series connection and a parallel connection. And you can convert parallel connection into a series connection. So what I was trying to do there was just to convert from parallel to series by showing that we've got a branch within a parallel connection, which is R1 and R2. In that case, it's R8 and R16. It can be combined to form one resistance or one resistor, and then from there you realize that we've got 1, 2, which are now in series because they are along that same wire. So you can still add these two to combine it into one resistor, of which you now realize that you've got that simple parallel connection that you normally that you normally see in grade 10 and 11. So but this is for grade 12, so you're able to see that you can just convert whatever parallel connection that you've got into a into a series connection, or combine the parallel into a single resistance. So guys, I think with this part I can say I'm done regarding the explanation of what I wanted to explain to you guys. This was not part of answering the questions, it was just to give you a bit of background. I think I'll need to do a special video just doing the circuits, where I'll be comparing a series connection and a parallel connection. So guys, something that I want you to notice, okay, doesn't really matter if it's that circuit, but otherwise let me just refer to that circuit to say wherever we've got a parallel connection, let's say this is a resistor, and again this is a resistor, this is 2 ohms, let's say this is 4 ohms, or let's say 14 ohms. Okay, so guys, you obviously know that you've got current flowing from the positive to the negative side of the battery. So you'll be having a current moving like that, okay, and when it gets to the parallel connection, you will have a portion of the current passing through that side, and again you'll have the other current passing through that side, and when they get there they join and they continue along that wire. Okay, so what I wanted to explain is that if you've got a potential difference, or if you've got a voltmeter connected across the 2 ohms resistor, let's say it's V and the reading is 7 volts. So guys, this V which is 7 volts of 2 ohms, is the same V as connected on that 14 ohms. Okay, very, very much important, guys. If you've got the voltage across the 2 ohms resistor, just know that that same voltage is the same voltage across the 14 ohms resistor. Okay, so that means a V connected across the 2 ohms is the same as V connected across that other resistor. Okay, so that's what I wanted to explain with regards to a voltmeter connected across one of the resistors in parallel. And the other thing that I want to explain is that you can see you've got 2 ohms, you've got 14 ohms which are connected in parallel. When you use that formula to combine these 2 resistors to form one single resistor, okay, just know that the resistance of the combination of these 2 is smaller than the smallest resistor. So what it means is that if you use that formula for R parallel, which is equals to R obviously of 14, is it 14? It's 14 plus R of, what is this, is 2. The R parallel that you get, the value that you get must be smaller than the smallest resistor of these 2. So if 2 is the smallest, obviously you've got 14 and 2, and 2 is the smallest. So your answer should be smaller than 2. If for some reason you are requested to calculate the combination or the R parallel of these 2 connection and you get a value which is greater than 2, then you know your answer is incorrect. Okay, so that means you must find a value which is less than the smallest resistor. Okay, so guys, I think for now we can straight away answer the questions. Okay, I hope as we answer the questions we'll be able to learn some more. But as I've indicated, I'm going to do a very special lesson where I'll be focusing on these two types of connections. Then from there you should be having a better understanding. So guys, let's see the first question. Okay, I see the first question. They're saying state Ohm's law in words. Okay, state Ohm's law in words. We won't waste time on this one. So what I can advise you is that if you have a definition of your own, you can always state that definition. It could be a definition from a book, definition from from your teacher, definition from your tutor, your mentor, whoever gave you the definition. You can always state that definition. Doesn't necessarily mean that the one that I'm going to state is the one that you should use. Okay, so state Ohm's law in words. So I'll just indicate you, and then from there you can either write it down. I'll also write it down. If you haven't got anything to write, it's fine. You can still write it down when you replay this video, because I'm going to make it available at the end of this lesson. So guys, if you haven't subscribed, please do subscribe so that you don't miss any uploads. Okay, so ladies and gentlemen, Ohm's law in words states as follows. Okay, the potential difference across a conductor, right? The potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Okay, so guys, there's a condition to this. This is provided that the temperature and all other physical conditions are constant. Okay, so I can just write it down. The potential, don't mind my handwriting, as long as you can hear what I say. The potential difference across a conductor is directly proportional to to the current in the conductor at constant temperature. Okay, and that condition can just write it in brackets to say provided a temperature and all other physical conditions are constant. So guys, remember, these are the wires, right? And you know sometimes the wires may heat. So when we're dealing with circuits, we assume that the temperature of these wires remains the same. There's no heat generated on those wires, okay? And again, we assume that the ammeters and the voltmeters are not having any impact on the circuit. So that means if that ammeter has got a certain amount of resistance, we just ignore it and assume it only measures the current without having to tamper with the current flowing there, or it doesn't have any resistance which resists some of the current to flow, okay? And again, same applies to a voltmeter. That's why in the statement, I'm not sure if it's stated there, but I remember there's somewhere where they said ammeter 1 and ammeter 2 represents ammeters of negligible resistance. So that means those ammeters connected on those wires, they don't have any resistance, okay? So again, there's no heat. So the reason why you might have an internal resistance is because, you know, guys, those cells, sometimes you can even feel the heat, okay? So that heat is as a result of internal resistance, okay? So guys, that was us answering question 9.1, okay? So that's how you state the definition or you state Ohm's law. So now let's move to the second question. So the second question says calculate the reading on ammeter 1, okay? So this question is allocated 4 marks. Obviously, guys, there was no need for us to mark the first question. It's obvious it's allocated 2 marks. So for just stating the Ohm's law in words, you score full marks, okay? So now the question says calculate the reading on ammeter 1. Where's ammeter 1? There, it's ammeter 1. What does ammeter read? Ammeter reads the current, okay? So they don't have to say calculate the current. They just say calculate the reading on ammeter 1. Then you know you've got 2 ammeters. Where's ammeter 1? There's ammeter 1. What does ammeter read? Then it reads current flowing there, okay? So ladies and gentlemen, very, very much important, okay? You should know that the current flow, obviously, remember the current flows from positive to negative. So that means the current will go in that way. When it gets there, it splits, okay? The other current will flow in that direction and the other current will flow in this direction, okay? Let me just indicate in terms of the arrows there to say, let me use these to say you're going to have the current flowing in that direction and another current flowing in that direction. So it splits, okay? And again, it doesn't necessarily mean that it splits in equal halves, okay? It depends on the resistance. If you've got too much resistance on this side, then more current will obviously flow through this side because it's less resistance on this side. So the more the resistance, the less the current. The more the resistance, the less the current flowing. The less the current, the less the resistance, the more the current. So because guys, we've got another branch within this parallel connection, obviously that current, when it gets there, it's going to split again. Part of the current will flow in that direction, part of the current will flow in that direction until it joins again. Then as soon as it joins, okay, then it means the current flowing there will be the same as the current flowing there. So that means this current, if it's 4, right, then that 4 will split. Maybe one will go that side, and then maybe 3 will flow this side. But we know 16, it's more, obviously this is where maybe 1 would flow, and that side more current will flow, and then when it gets to that point, it's going to join. So in short, the combination of the current flowing there and there is the same as the current flowing there or flowing there. Obviously that current is going to pass through there, and then it joins. As soon as it joins, then it's that current which is the same. It splits, joins, flows, joins, and then obviously there, this is where it split head, and then it joins. So guys, you should just visualize. Otherwise, if you're failing to visualize that, just think of water, guys, and regard these wires as the pipes. Okay, so obviously water will flow, and when it gets there, it's a T-junction. You know, you've got a T-junction connecting the pipes. Okay, so obviously some water will flow through that side, the other water will flow through this side. It will just flow until it gets to that point. The same water will flow, and again you've got another T-junction there. Then the other will flow in that direction, the other will flow in that direction, then they will flow, and then from there they join, they continue, and then they get to that point, they join again, then they go into the main pipe. Okay, so I hope you are able to visualize, guys. So now what does the question wants us to calculate? The question wants us to calculate what is it? Let's check. The question says calculate the reading on ammeter A1. Okay, so let's see where's the reading there. Okay, so ladies and gentlemen, I was just checking this. I just wanted to see that statement. Can you see? They say with switch S closed, the current passing through the 8 ohms resistor is 0.5 amperes. Very much important, guys. You've got the current passing through, let's see, the 8 ohms resistor, which is a 0.5 amperes. Okay, I hope you're able to see there. So guys, that means if we've got the the current flowing through the 8 ohms resistor, we can calculate the V of that 8 ohms resistor, and we know from the initial statement or the initial lesson that I've given, I just indicated that the V of 8 ohms resistor is the same as the V of 16 ohms resistor. Okay, so that means we can be able to calculate the current flowing there and there, and we know the sum or the combination of these two current is the same as the current flowing or passing through ammeter 1. Okay, so guys, in short, what I'm saying, or what I said with that statement, is that V of 8 ohms is equals to V of 16 ohms. I hope you remember this part, guys. Okay, so if this is the case, then let's calculate the V of 8 ohms resistor. V of 8 ohms resistor is equals to, obviously we know the formula, V is equals to IR, right? So we've got a formula which says V is equals to IR. It's there on your formula sheet. And again, we've got another formula which says EMF is equals to I into capital letter R plus small letter R. Okay, so we might need to use both of those formulas, but it doesn't really matter for now. I just wanted you to be aware that we've got these two formulas. They are very, very much important. At some point, we might use both of those formulas, or somewhere we might just need to use one. Okay, so sorry, in this case, as you can see, we just need only one formula there, which is IR. Okay, then we know the I of 8 we're just given is 0.5, and what is the R? It's 8. Okay, this is where you can just pull out your calculator, and then from there you can just punch on a calculator. 0.5 times 8, it's actually half of 8, which is 4 volts. Okay, so that means a V of 8 is equals to 4 volts, which is the same as V of 16, which is 4 volts. Then how about we calculate the current flowing through the 16 ohms resistor? It's more like water, guys. We want to know the amount of water flowing that side and this side. We know the combination of the water flowing that side and that side is the same amount of water flowing through that ammeter 1, which is the same as the water flowing through that 20 ohms resistor. Okay, so guys, now we can just calculate the V of 16 ohms, right? Obviously the same formula. We know what is it? There's something that we don't know. Obviously, it's not the V that we're calculating, but the current flowing through the 16 ohms resistor. I just noticed after writing this formula. So it helps to start by writing the formula, because you'll be able to see what you have and what you don't have. So we know that the the voltage on the 16 ohms resistor is 4, which is equals to, we want the current flowing through the 16 ohms resistor. Obviously the resistance is 16, so that means I is equals to 4 divided by 16. Okay, so let me see how much is that. 4 divided by 16, it's quarter, which is 1/4. In decimal, it's 0.25. Remember to write the units. Okay, so that means ammeter 1. Okay, the reading on ammeter 1, which is the current on ammeter 1, it's equals to the current flowing through the 16 ohms resistor plus the current flowing through the 0.5 ohms resistor. Okay, and it's actually the total current flowing through that parallel connection, or that branch of the parallel connection. Okay, so that means we've got 0.25 plus what is it, plus 0.5 plus 0.5, which is equals to 2 plus 5 is 7, so it's 0.75 amperes. Okay, so this is how you solve this question. Okay, question 9.2. So that means the current flowing there, it's 0.75 amperes. This is 0.75 amperes. So that means the current flowing there, it's 0.25 amperes. Okay, very much important, guys. And again, we know the V there. Let me just write it there, but you'll remember that we didn't have that V, so that V is equals to 4 volts. Okay, I just wrote it there, but you know it's a V connected across the 16 ohms resistor, which is the same as the V connected across the 8 ohms resistor. Okay, so guys, that part, let's see where we score our marks. So obviously you might be lucky and score a mark from writing the correct formula, which is V is equals to IR. Okay, and the other mark will come from correct substitution, and then from there they just give you a mark for calculating the the current flowing through the 16 ohms resistor, and your last mark will come from the final answer where you indicate the current flowing through that ammeter. So that means this question is allocated 4 marks. Okay, so guys, let's now move to the next question. I assume you fully understand how to solve this question. Okay, so let me just, I think I can wipe all of this because I assume you've already seen and you understand exactly how to solve that question. So now, guys, let's move to question 9.3. Okay, so let's check what the question says. So the question says, if device R delivers power of 12 watts, calculate the reading on ammeter 2. Okay, so they're saying if this device R delivers power of 12 watts. So let's see if it delivers power of 12 watts. Okay, then calculate the reading on ammeter A2. So guys, for the fact that we're given a power there, we might need to know the formula for calculating power, because at some point it might assist us to calculate what the question wants. So I'm just quickly going to check the formula sheet, okay, and look for that formula for calculating the power. You've got a lot of formulas of which you need to be careful of which formula to use. So these are the formulas that we use when it comes to the circuits. Can you see? So I think it would be best to just go for the simplest formula. You might, in some cases, need to use a different formula. And again, also for this question, you might do it differently, but I just want to show you the simplest way of doing it. So there you've got P, which is equals to VI. So we've got P, which is equals to VI. Okay, so guys, let's see. Have we got the power? We do have the power. They said is 12 watts. Okay, which is equals to the V. Have we got the V of R? We don't have that V of R. And obviously I, it's what we want to calculate. I of ammeter 2. I think that's what the question said. Let me just quickly check so that we're 100% sure. Okay, there's the question. The question says, if device R delivers power of 12 watts, calculate the reading on ammeter 2. So this question is almost the same as that one. So that's why our approach might also be the same. Okay, so guys, let me see. I'm just trying to think of the easiest way of approaching this question. Okay, but let's see. we can calculate a V on that 20 ohms resistor. Okay, remember we've got a V for this branch. Okay, so if we combine the voltage of these two resistors, okay, so we can still apply the same rule where the V of this combination will be the same as the V of R. I'm not sure if you remember, guys. You remember we said if we've got a connection, this is R and then this is a resistor. We said if we can have V there, okay? So this V is the same as that V, right? I hope you remember. So let me just quickly explain to you what I'm thinking so that you are able to follow. So what I'm saying is, now that we know, remember this is that parallel combination. What if this parallel combination, we combine it, and then from there we combine it with that one, then we just have one, and then from there what we do, this is A, what we do, we then calculate this V. As soon as we have this V, we know that V is the same as that V. Then we can just substitute that V there, then we'll be able to calculate the current through the 2 ohms resistor. I think this will work, guys. Let's just give it a try and see how far we can go with that. So let's see, we've got that V there is 12. Let's try to calculate V there. Okay, so that means V at 20 ohms resistor, we know V is equals to IR, right? So what is the current flowing there? Obviously we've calculated it, it's 0.75, right? It's 0.75. What is the R there? It's 20. Then let's see, it's 0.75 times 20, it's equals to 15. So it's equals to 15 volts. So that means we've got V there, we've got A1, we've got V there, then we've got that R, we've got that ammeter 2, ammeter 2. Okay, so we know, guys, that V there, we just calculated it, isn't it? How much was it? It was 4V. Can you see there? That V, it was 4V, right? We just calculated this V now. It's 15V. Okay, so what I'm saying, guys, what I'm saying is, if we sum these two V's, then it means we just have one resistor there with just one V. Then what will be that V? Obviously 14 plus 15, which is going to be 19V. So that means that 19V across this one resistor is the same as the V across that R. I'm not sure if you fully understand, guys, but this is what we've done on question 9.2. I think if you can just try to replay this video over and over again, you will be able to have a full understanding. So let's see, this is the V, so that means we can say V total is equals to, obviously this will be 4 plus 15 volts. This is that 4 volts plus 15 volts, okay, which is equals to 19 volts, right? So now we can substitute into that formula, which is P is equals to V I. So we know power is equals to 12. Okay, we're given that power as 12 watts, which is equals to V, we just calculated V, multiplied by the current flowing through ammeter 2. Okay, so that means the reading on ammeter 2, which is I, is equals to 12 divided by 19. Let's see, 12 divided by 19, it's equals to 0.63. I'm sure you also get the same answer when you punch on a calculator at 0.63 amperes. Okay, so this is the reading on ammeter 2. So guys, that's how you answer this question. Okay, so this question, it's as easy as it is, guys. Now I'm just quickly going to show you where you score some marks on this question. And remember, I think this question was allocated 5 marks. Okay, so guys, let's see. Where do you score your first mark? They'll obviously give you the first mark there for writing that formula, and again for you to calculate that V, they're going to give you a mark, and again they also give you a mark for for that formula. Obviously, you know, after the formula they give you a mark for correct substitution, and obviously your last mark will come from your final answer with the correct SI unit. So the unit for current, it's amperes. So you shouldn't write 0.63, but it should be 0.63 amperes. Okay, so guys, that's how you solve for question 9.3. So in terms of the current, guys, in terms of the current, that means the current flowing there, it's 0.63 amperes. Okay, so let's just do some comparisons, guys. Let's just do some comparisons. Can you see there on that branch? Okay, we've got 16 ohms resistor, we've got 8 ohms resistor. You've got 0.5 amperes, you've got 0.25 amperes. So can you see more current is flowing through that resistor which has less resistance, okay? And less resistance flows through that current which has more resistance, okay? So now you've got the combination of these two resistors, which is 0.75. So that means the current which is being shared amongst these two resistors is 0.75. So that means as the current flows there, it's sharing that 0.75. So a part of it will flow through that side, a part of it will go through that side, and when it gets to that point, is the combination of these two currents, then it's 0.75. So when it gets there, and obviously from that side, when it gets there, it combines, it joins. Okay, so that means the current flowing there is the combination of these two currents. I'm not sure if you understand, guys. So for example, there you've got two currents. When you combine these two currents, they give you the current flowing there. Okay, so this current flowing there, as it joins with that current flowing from that side, when it gets to that point, it combines. Think of it as water flowing from that pipe, another water flowing from that pipe. When it gets to that point, it joins, and then it means you've got this amount of water and this amount of water. So that means current flowing there, it's equals to that 0.75 plus 0.63 amperes. So this is the current total, or the current external. Okay, so that's what we talk about when we say the external, or the current flowing through the external circuit. So everything here was flowing through the parallel connection, even though within this parallel you still have a branch there. So now you've got this current flowing through the external resistance, and it also, the same current flowing externally is the same current passing internally through that internal system. or through that battery. Okay, so that same current, so that means, in short guys, let's just check what is 0. What is I'm not sure if you know, when your calculator gives you some problems, you just have to hit it hard. I'm not sure if, okay, now it's working. So guys, let's see, just say 0. What is it, 75, okay, then plus 0.63, this is 1.33. okay, so that means this is 1.33 amperes. Okay, so what I'm saying guys is that the current flowing on that black wire, okay, it's it's 1.33. okay, so guys, let's now move to the next question. Maybe you'll have a better understanding when we move to the next question. Okay, so I'm just going to wipe all of this. So guys, I'm not really sure if I picked a difficult question, but you know, when we do these difficult questions, you are able to see that, okay, questions may be as difficult as it seems on this lesson for today. Then you are able to know the amount of work that you need to invest into practicing this kind of questions. I do agree if one says it's a bit difficult, but it's easy if you understand the circuits. Okay, so you shouldn't study the difficult ones. Start with the the simplest ones, which are in your textbook. Do those examples. From there, that's when you can try the question papers. So guys, we've got 9.4, which says calculate the reading on the voltmeter when switch S it's open. So they want the reading on the voltmeter. Okay, so this is what they want. This question is 9.4 and it's allocated how many marks? 3 marks. So it's allocated 3 marks. Okay, so what they want is that reading on V. Okay, so we know we've got EMF, which is equals to we know the formula, it's I into capital letter R plus small letter r. Okay, so if we expand this formula guys, we know this is I times r, I times smaller r. We know V is equals to I r. Okay, so that means this I multiplied by the capital letter R, let me just write it down, plus I small r. So this is the external V and this is the internal V. Okay, so guys, this is V external plus V internal. Okay, so the reason why I'm doing this is because we already know what is the external V. Okay, so the external V, remember guys, the external V is that V which is what was it? I think we've calculated that external V, and if I remember very well, it was what was it? I think it was 19. It was 19. It was 19. What was it? Wasn't it 19 volts? I think it was 19 volts. Because if you remember, the external V, it's that V across this 19 ohms resistor. So you can just go back to the previous question. You'll remember that this was 19 volts. Okay, so this is the external voltmeter. So now have we got the internal voltmeter? This is what we can calculate because we've got enough information. So let's say V internal, it's equals to, we obviously know that it's I times small r. Okay, so what is the current flowing there? It's the combination of those two. Okay, which is 0.75 plus 0.63 close multiplied by 1. What is 1? 1 is that small r. Okay, so remember guys, I hope you're not confused by this part, because I've just indicated that the current flowing there and the current flowing there combined is the current flowing through the black wire, and you can see the black wire it's passing through that system or that battery. So now that means you've got 0.75 plus 0.63 close open times 1, and this is equals to a 1.38 volts. Okay, let me see, because I've added those two. I'm not sure what happened for me to get a 1.33. Let me see, 0.75 plus 0.63, that's equals to, yeah, no, I got I got 1.38. It's just that I wrote it incorrectly there, but I hope you were able to notice on your calculator when you punch in that you've got 1.38. As I've said in the previous lessons, guys, it's very, very much important that when I do this type of questions, I make mistakes, because you'll be able to notice how I recover from those mistakes. Okay, and again, there's a value in every mistake, so you must at all times make sure that, especially when you practice, you make those mistakes so that you're able to consult with your teacher. They're going to show you where you made a mistake. Make sure to ask them, why did you make that mistake? Make sure to ask this question. Just ask them, say, why did I make that mistake? Then based on the information that you know, they will be able to check what was your approach, what were you thinking when you're doing this. In that way, that's how you'll be able to detect the things that makes you to make the mistake. If it's the issue of information, then in conclusion, you will know that you need to go and read some more, so that you don't make minor mistakes as a result of you not being aware of some of the information that you didn't read about. Okay, so guys, our question is almost done. We now have the V internal. Okay, so if we have the V internal, we can use that formula, because we know now the V internal is 1.38. Okay, so that means the EMF, it's equals to 19 plus 1.38, which is equals to obviously 20.38 volts. Okay, what are you noticing here, guys? Someone would say, I'm actually noticing that V is actually reading the EMF. Okay, so that means that V there, it's measuring the EMF. Okay, very, very much important, guys. Very, 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 very much important. So where do you score some marks? Okay, so let's see. If I'm marking your paper, then I'm going to give you a mark for just writing the correct formula. So it's either you wrote that formula, this formula, or that formula. I'm just going to give you a mark. Okay, so after getting a mark for that formula, then I know you already have this as your V external, so I don't need to give you a mark there. I can give you a mark for actually calculating that internal voltmeter, the internal voltage. So I can give you a mark there, and again, I know you already identified the formula to calculate the EMF, so your last mark comes from the final answer. So ladies and gentlemen, this is where you score your 3 marks. So this brings us to the end of our lesson for today, and I hope you enjoy it. So guys, if you've watched this video until this far, please do make sure that you subscribe if you haven't subscribed, and hit the bell notifications so that you're notified of future uploads. And please do make sure to like the video if you feel like it was worth it. So guys, this brings us to the end of our lesson. I thank you very much for joining. My name is Desmond, and I'm signing out.